Hello students! As we have already discussed about three kinds of operators and operations, now in this video we'll discuss about the major types of operators in detail. As we have already studied about high-level programming languages, hence these languages use large number of operators for their functionality. Thus, operators are further classified into the following categories: arithmetic operators, relational operators, logical operators, bitwise operators, assignment operator. Beginning with arithmetic operators. They are also called mathematical operators. Computer programs are widely used for mathematical calculations. We can write a computer program to perform simple mathematical operations like addition. Let's take an example. 30 plus 90 is equal to 120. Here, 30 and 90 are the operands, and we shall use the operator plus to add these two numbers. We will use the operator plus. This is an addition operator from the arithmetic operator series. This example is also an example of binary operation. Other arithmetic operators include subtraction, multiplication, division, and modular division, etc. In subtraction, we subtract two numbers as we have seen in the example. Multiplication is used to multiply numbers. Division, in which we use / division symbol to divide the numbers. In modular division, the operation divides two operands and returns the remainder of division operation as a result. It is also termed as remainder division. In the example, 57 is divided by 2 and 5 is the remainder. Arithmetic operators are of utmost importance in programming languages to handle operations on routine data. Next, we have relational operators, which are used to compare the value of operands, and these operators are usually applied with a conditional expression which satisfies a condition. There are a number of relational operators available for programming languages. Some common relational operators which are used in C, C++, and Java languages are the equal to operator, which tests whether the two operands are equal or not. The not equal to operator, which tests whether the two operands are not equal to each other. The less operator tests whether the first operand is less than the second operand. The greater operator tests whether the first operand is greater than the second operand. The less than equal to operator tests whether the first operand is less than or equal to the second operand. The greater than equal to operator tests whether the first operand is greater than or equal to the second operand. So, these operators are used to compare the operands with each other in one way or another. The next category we have is logical operators. These help us to take the decision according to the condition given to us. Three types of logical operators are: logical AND means binary multiplication. Logical OR means binary addition. Logical NOT means the complement. Just have a look at the truth table of logical operations. If A is equal to 2 and B is equal to 0, then A and B will be 0 because 0 multiplied by 0 is equal to 0, since AND means multiplication. If A is equal to 0 and B is equal to 0, then all B, A or B will be 0 because 0 added into 0 is equal to 0, since OR means addition. If A is equal to 0, then not A will be 1 because complement of 0 is 1 and not means complement, and so on. Next category is bitwise operators. These are the same as the logical operators. The difference is that bitwise operators work on bit scale, meaning binary representations of data. The meaning of bitwise is the combination of two bits. For example, 0 is a single bit and so is 1, but 0, 1 are two bits and so on. These operators are used to manipulate values for various purposes such as calculations and comparisons. Let us discuss different types of operators. First type is bitwise OR. A bitwise OR performs logical inclusive OR operation on two bit patterns. If both the bits are 0, then the result is 0, otherwise it is 1. As 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, 1 plus 1 is equal to 1. Next, we have the OR addition operations of more than one bit. First, we have 0, 1, 1, 0 and second 0, 1, 0, 1. The result after the OR operation will be 0, 1, 1, 1. So it means bitwise OR operation is used to perform inclusive OR on 2-bit pattern. Next we have bitwise AND. A bitwise AND performs the logical AND on the two binary patterns of the same length on their corresponding pairs of bits by multiplying them. The result is 1 if both the bits are 1, otherwise the result is 0. See the truth table as 0 into 0 is equal to 0. 0 multiplied by 1 is equal to 0. 1 multiplied by 0 is equal to 0. 1 multiplied by 1 is equal to 1. Next, take an example to perform the AND operation on bits. 0101 and 1011 is equal to 0001 based on the truth table of it. So, you need to understand truth table very clearly. Next, we have bitwise NOT. The bitwise NOT is a type of unary operation also known as complement operator. This operator performs logical negation on every bit. It basically converts bit 1 to 0 and bit 0 to bit 1. Just look into the example. NOT 0101 is equal to 1010. Bitwise XOR. A bitwise XOR takes 2-bit patterns of equal length and performs the logical exclusive OR operation on each pair of corresponding bits. The XOR returns 0 if both bits are 0 or both are 1, otherwise it returns 1. See the example. 0100 XOR 0101 is equal to 0001 is the result by using truth table. Next, just have a look on combined truth table of all bitwise operators. Next, we have bit shifts operations. The bit shifts are sometimes considered bitwise operations because they treat a value as a series of bits rather than as a numerical quantity. In these operations, the digits are moved or shifted to the left or right position. Registers in a computer processor have a fixed width, or some bits will be shifted out of the register at one end, while the same number of bits are shifted in from the other end. The differences between bit shift operators lie in how they determine the value of the shifted in bits. First type of shift operation is arithmetic shift. In an arithmetic shift, the bits that are shifted out of either end are discarded. Next is the type of arithmetic shift that is left arithmetic shift. In a left arithmetic shift, zeros are shifted in on the right. Just look into the example. Left shift 000101111 is equal to 00101110. Next is right arithmetic shift. In a right arithmetic shift, the sign bit, the most significant bit MSB, in 2's complement is shifted in on the left, thus preserving the sign of the operand. Take an example. Right shift 000-10111 is equal to 000-1011. Next, we have logical shift category. In a logical shift, zeros are shifted in to replace the discarded bits. Therefore, the logical and arithmetic left shifts are exactly the same. It has two types, left logical shift and right logical shift. Before moving towards the left shift, let's first discuss about LSB and MSB. As it is shown here, the rightmost bit of number is called least significant bit and leftmost bit of number is called MSB. Now the question arises, why these are named as LSB and MSB? To understand this, let's take an example. Here, LSB is 1 and MSB is 0. If LSB is changed due to some error, number will become, and initially number has, so number is changed from 1 to 0. But if MSB is changed, number become 101 means 5. So it becomes 5 from 1. So it is a major change, that is why it is called MSB. Now let's move towards left logical shift. Take the binary number 000-10111. In this, the MSB becomes the LSB and remaining bits shift towards left side one by one. For example, if the binary number is 000-10111, here 0 is MSB and 1 is LSB. So, the MSB becomes the LSB and remaining shift on left side. So, the number becomes 00101110. Right logical shift. Take the example 0001011 is equal to 00001011. In this, the LSB becomes the MSB and remaining bit shifts towards the right side one by one. For example, if the binary number is 000-10111, here 0 is LSB and 1 is MSB. So, the LSB becomes the MSB and remaining bits shift on right side. So, the number becomes 00001011. Next, we have a major category, assignment operator. This operator simply assigns the value of variable on its right-hand side to the variable on left-hand side. Take an example, Sam is equal to a person. It simply assigns person to name Sam. It means Sam is a person. So, we have studied the various types of operators, arithmetic, comparison, and logical, etc. Thank you.